In this section, we will talk about the frequency, the relative frequency of observed outcomes, and introduce the concept of distribution. In the previous video, we talk about a dice game. The sum is a random variable and we got 10 observed outcomes. We tried 50 times and get 50 realized outcomes. Now, we want to know the frequency of this collection of outcomes. There is a very useful method of data frame called value count. It outputs Panda series, which has only one column if compared with data frame. Its index is a list of different outcomes and the value column is the frequency. We can also sort these series according to the index using sort index. For example, in this picture, the second row means that the frequency for an outcome of 4 is equal to 5. We can also plot frequency using this line of code. If we want to compare the frequency of different trials, we have to convert frequency into relative frequency. Relative frequency equals frequency divided by a number of trials. With relative frequency, the shape of the bar chart does not change. The scale of y-axis changes. When we increase the numbers of trials, for example, the relative frequency becomes more and more stable as you increase the number of trials. This is a bar chart showing the frequency for the outcomes of 10,000 trials. Distribution of a random variable is a table consists of two sets of values. One for different values of outcome, the other lists the probability for each value. Here is the distribution table. We can compute all probability for x using Python here. X distribution is a distribution table we built. From this distribution table, we do not know the shape of the outcome immediately. Usually, the mean and the variance is two characteristics of the distribution of random variables. The mean of a random variable is also called expectation. These two formulas are general formulas for the mean and the variance of a discrete random variable. Xi here is the only possible outcome. Pi here is the probability for this outcome. The mean is the average of all outcomes weighted by probabilities. Similarly for variance, which describes the variation of the outcome. At the bottom, it is the code to compute the mean and the variance given distribution table. What is the distribution for continuous random variables? We'll compute the probability for continuous random variables. We will start with the simplest continuous random variable, which has a uniform distribution. This kind of variable takes possible values with an equal chance in a certain range. Here's a distribution graph for the uniform random variable, which takes values of 0 and 100 with equal chance. The height is not a probability. It will represent the value of a density function, which is applied to compute a probability for continuous random variables in this way. The area under the density curve is the probability. Hence, the whole area between 0 and 100 is equal to 1. Because this random variable can only take a value in this range. Here's a summary. For discrete random variable, you can find probability easily by checking the table of distribution. It is more complicated in the continuous case. It is the area under the probability density function, in short, PDF curve. PDF can take any shape. You should be careful to note that PDF is not a probability. Now, let's go back to finance questions. Why we need a continuous random variable? Because the distribution of stock data return is continuous. We know that real distribution stock return cannot be directly observed. Not like the dice game. In the next section, we will talk about models of distribution that can describe the data return.